Alright guys, we've been working on the chain rule and I want to do some tougher examples. The examples we do here are going to be things where we use the chain rule maybe multiple times, or maybe we use the chain rule in conjunction with the product rule or the quotient rule. So let's start here. One thing about taking derivatives is you work your way from the outside in. So on this first example where we've got f of x is 1 minus x over x squared plus 1 to the third, we're going to deal with that third power first and then work our way inside. So I'm going to get f prime of x is 3 times this squared, and then times the derivative of what's inside. Now, due to the derivative of what's inside, we got to use the quotient rule. So it's going to be low d high, which is -1, minus high d low, which is 2x, over low squared. All right. Now, to avoid copying this too many times, what I want to do is I want to work out what this stuff is up here. I'm just going to work it out in place and do it in a different color above it. So let's see, distribute that -1 through there, you get minus x squared minus 1. And then distributing this negative and the 2x through there at the same time, we're going to get minus 2x squared, or no, just minus 2x, and then plus 2x squared. All right, so let's rewrite it. F prime of x equals, I'm going to do two things here. I'm going to write my 3 as 3 over 1, and I'm going to take this and split it into, instead of since we've got a fraction and it's squared, the whole fraction is squared, we can break it into 1 minus x squared over x squared plus 1 squared. Then this on bottom, we've got x squared plus 1 squared. And the nice thing about this, the reason I break this up is now we can multiply across here and we can multiply across here once we've worked out what this last numerator is. This last numerator, let's see, we got 2x squared minus x squared, leaves us with x squared. Then we got minus 2x minus 1. And so I can multiply across and get the top is 3 times 1 minus x squared times x squared minus 2x minus 1. Then below that, I'm going to have x squared plus 1 to the 4th power. And that's the answer. All right. Let's do this next problem. This next problem says find the derivative of g of x equals sine of 2x to the 10th. Now, what's going on here is we've got three functions nested together. We've got the sine on the outside, we've got raising to the 10th in the middle, and then 2x is the innermost function. So again, we're going to work our way from the outside in. First function to deal with is the sine. So g prime of x is going to be derivative of sine is cosine of everything that's inside of there. Now, if you want to, you can scribble this out and say, okay, now let's take the derivative of that inside function. That's going to be 10 times 2x to the 9th. Then times the derivative of the inside function there, which is 2. And there's not a whole lot to do here as far as simplifying. Only thing I'm going to do is I'm going to put the 2 and the 10 together. Make this 20 times 2x to the 9th times cosine of 2x to the 10th. If you wanted to, you could split the 2x in parentheses to the ninth. You could split that into 2 to the ninth times x to the ninth. Then that 2 to the ninth you could combine with the 20, but I wouldn't worry about it. And certainly if that had been something more, if this had been, say, 2x plus 5 or something like that, you wouldn't want to touch it. You'd want to just leave it there. All right, this next one's another one where we got 3 functions nested together. We got tan of e to the 5x. So we'll start from the outside. Derivative of tangent is secant squared of e to the 5x times the derivative of e to the 5x is e to the 5x. But then that 5x is an inside function, and we got to multiply by 5. And I would probably rewrite that as 5 e to the 5x secant squared of e to the 5x. All right. Okay, what about this one? Find the derivative of this thing. This is actually badly written. Let me adjust it, because this is f of t, and then we've got an x and a t over here. I'm going to change that x to a t. That's just a typo. Okay, so there are a couple of ways we could do this one. The way that's jumping out at me right now, because we're doing all this stuff with the chain rule, is to treat that 7 as an outside function and t squared e to the t is the inside function. So if we do that, we get f prime of t is 7 times t squared e to the t, 6th. And now we got to multiply by the derivative of what's inside, and we got to do that with the product rule. So derivative of t squared e to the t, you get first times derivative of the second plus second times derivative of the first. Let's see, what can we factor out of this? We can factor out a t, and we can factor out an e to the t. And what are we left with? Let's see. We're left with t plus 2. And I'm going to leave my answer like that for now, because there is another way we could do this problem. We could have taken the original up here and rewritten it as f of t equals t squared to the 7th, which is t to the 14th, then e to the t to the 7, which is e to the 7t. Maybe it's worth writing that in 2 steps, because what we're doing here, we're distributing the 7 across here. And when you have a power to a power, you multiply those powers. So this is t to the 14, then e to the 7t. So we could do that first, and then take the derivative, just using the, let's do that. I'm going to do that in purple. If we do that, we get f prime of t is equal to first times the derivative of the second. Now the second thing here is e to the 7t, so its derivative is e to the 7t times 7 plus the second times derivative of the first, 14t to the 13. Now out of these I can factor out, let's see, e to the 7t, and t to the 13th, and I'm left with t times 7, so 7t plus, oh wait, I can factor the 7 out as well. So let's see, what's left over here? t to the 14th, so there's a t left. And then we factored out e to the 7t and 7. Over on this side, we factored out e to the 7t, we factored out the t to the 13, and we factored out a 7, so there's a 2 left here. And we get this. Now, if we wanted to, we could go back through up here on the other problem and we'd get the same thing. I just noticed though, I made a copy error. There's supposed to be a 6 there. But we could go through here and we get the same thing if we multiplied this out. All right, do I have any more examples? No. But I am going to come back and do another video with some additional examples because the chain rule is really important and I want to give you more examples than just what are right here.